Okay, we're going to look at a problem from the last exam. This is number 15, and it was worth quite a few points, so I wanted to talk about it. The problem was, here is a polynomial. It's a degree 4 polynomial, and they tell us 3 and negative 3 are two of its zeros, and they want us to find the remaining zeros. Okay. Well, real quick, what a couple of people tried to do is look for x-intercepts on the calculator. And that's okay. You can certainly see that these two numbers are zeros, they're x-intercepts, and you can find two others. But the problem is we want the exact form of these zeros, and you can't identify that from the calculator. You can get a decimal approximation, but we can't see what they are exactly. The other issue that comes up is if the zeros are complex numbers, we can't identify those as x-intercepts. So in the problem you're asked to find these in exact terms. Basically tells us the graphing calculator is not going to be a whole lot of help here anyway. So here's how we do this problem. Because 3 and negative 3 are zeros, we know two of the factors of the polynomial. Okay, so basically kind of up here we can think of this. The polynomial has 3 for a zero, and one of our theorems called the factor theorem in the book says if a number is a zero, x minus that number has to be a factor. Okay. So what we're going to do to start and eventually find all the zeros is we're going to factor this polynomial, at least partially, and we know what one of the factors is, x minus 3. So I'm going to begin by taking the polynomial and dividing out x minus 3. Okay, so I'll do that below here. Now what I'm going to use is synthetic division, so I have to set that up. In my synthetic division, to divide out x minus 3, I will put 3 outside here. And now I need to write the coefficients of that polynomial, which are 1, negative 6, right? It's 1x to the fourth, negative 6x cubed, and then negative 3, what do we have? 54 and negative 54. Okay, so I'm going to proceed to do the synthetic division, which will give me the quotient, and I know the remainder is going to be 0. You'll see that in a minute, but I know that's going to happen because if 3 is a 0, x minus 3 has to factor out. Okay, so I drop down the 1. 1 times 3 is 3. Okay, so now I add negative 6 plus 3 is negative 3. Multiply by 3 again, and I get negative 9. Here I add and I get negative 12. Multiply by 3 again, and I get negative 36. I add here and I get 18. 18 times 3 is 54, and when I add that to negative 54, I do get 0. So x minus 3 does factor out, leaving us a quotient given by those four numbers. So the quotient would be 1x cubed minus 3, I think it's 3x squared. What do we have next? Negative 12x minus 18. Okay. Oh, I'm sorry, it's plus 18. Okay. So that's from the quotient and the division. Okay, so that's a big help. Now what I can do is continue trying to factor this polynomial that I have as my quotient. So that's where it helps to know another 0. Okay, so not only does x minus 3 factor out, because 3 is a 0, since negative 3 is a 0, x minus negative 3, which is just x plus 3, has to factor out as well. Okay, so I'm going to proceed to factor out one more factor. And again, I'll do that with synthetic division. The key is we're not dividing into the original polynomial, we're going to divide into this one, because that's what we want to pull the factor of x plus 3 out of. So down here below, I go ahead and I set up another synthetic division. Here we're dividing out x plus 3, so negative 3 goes outside. And I write the coefficients of the polynomial I'm dividing into, which in this case are 1, negative 3, negative 12, and 18. Okay. Now again, that didn't look too good. Again, we know x plus 3 factors out, so we should get a remainder of 0, but we'll go ahead and do the division anyway and see what happens. So we drop down the 1. 1 times negative 3 is negative 3. Okay. Add here and we get negative 6. Okay. Negative 6 times negative 3 is 18. Add here and we get positive 6. And 6 times negative 3 is negative 18, and of course when we add those together we do get 0. So x plus 3 does factor out. Okay, and now since we're kind of progressing along, we want to write that remaining quotient that we're going to have after the second factoring. and that'll be 1x squared minus 6x plus 6. Okay. Now, basically, we're ready to kind of wrap up the problem now. To find the zeros of a polynomial, you can factor it and set each factor equal to 0. Okay. Now, you might say that this quadratic can be factored further, but the good news is we don't have to do that, because we can also set a quadratic equal to 0 and solve that using the quadratic formula. Okay. So if you set each factor equal to 0, you will get all of the zeros exactly. If we set x minus 3 equal to 0, of course, that's a simple equation. We would get one solution, x equals 3. If we set this factor equal to 0 and subtract 3, we'll get another solution that we were aware of, negative 3. And then the two remaining solutions come from solving x squared minus 6x plus 6 equals 0. And again, instead of factoring, we use the quadratic formula. Okay. And I'm going to skip that part because I think a lot of you have seen that and are very familiar with it. But when we do that, we get the last two solutions, which turn out to be 3 plus or minus the square root of 3. Okay. So those are the two remaining solutions. They are real numbers, but they're not simple. They're not rational numbers. So if you try to find these as x-intercepts on the calculator, all you're going to see are just decimal numbers. I think one of them turns out to be like 4.78 something, but you would have to know that that's exactly 3 plus the square root of 3. And even then, you really haven't proven that that's a 0. You just have identified a number that's close to what the calculator's telling you. But in any case, we want to be able to find these without the calculator, essentially. So that's why we need synthetic division. Okay, thanks.